welcome to the first lesson on integration for additional maths. Let's get started. By now you should be able to differentiate quite easily all of these functions. If we've got y is equal to x to the power of 3, we bring the power down and multiply by it, and then reduce the power by 1. So we get 3x squared. Or if we've got this one here, the first term is the same. And if we have a look at that 6, we could actually write that as 6x to the power of 0, x to the power of 0 just being 1. And when we differentiate that, we bring the 0 down to the front and reduce the power by 1. But anything multiplied by 0 is equal to 0. So when we differentiate that 6, it disappears. We don't have it anymore. So we've got the same thing. And in fact, this one, where we've got x to the power of 3 minus 7, we're still just going to get dy by dx is equal to 3x squared. And in fact, it doesn't matter what this is. We can call it an arbitrary constant. Any number that doesn't have any x's or any other variables in it is going to disappear when we differentiate it. And so for all of these, we're going to get dy by dx is equal to 3x squared. So the question, of course, is how many equations are going to give us dy by dx is equal to 3x squared when we differentiate them? And the answer, of course, is an infinite number, because we can have any sort of constant. We've got y is equal to x to the power of 3 plus c. There's an infinite number of numbers that could be c. So when we differentiate them, they're always going to give us 3x squared. Now, that's a differential equation, dy by dx. And if we wanted to get back to having y is equal to something, we need to do the opposite of differentiation, and that's called integration. And that's what we're going to be doing today. So, we need to do the opposite thing. Differentiation, we multiply by the old power and then reduce the power by 1. So we're going to go backwards through that. Integration, we add 1 to the power and then divide it by the new power. And always remember to add a constant. Okay, so if we look at it algebraically, if dy by dx is equal to x to the power of n, we add 1 to the power and then we divide by the new power. Okay, let's do some examples. So, if we've got that dy by dx is equal to x to the power of 6, when we integrate that, we're going to add 1 to the power and then divide by the new power. With this one here, 5x to the power of 4, when we integrate it, we're going to have 5x to the power of 5 divided by the new power of 5, and of course we can cancel that down to just get x to the power of 5. Now I've just done a classic mistake. Don't do this. I've forgotten to add the constants. So, because there could have been a constant before it was differentiated, when we integrate, we need to make sure that we put the constant back on. But we just don't know what it is, so we're going to call it c. And this one here, I can then put the constant on. Okay, so the last one here, when I integrate that at the moment is 7x to the power of 0. Add 1, so it's 7x to the power of 1 divided by the new power, which of course is just 7x. And again, I've forgotten to add the constant. Maybe if I forget lots, you guys will remember. Anyway, I think it might be time for you to have a go. So, have a go integrating these 4 functions. Pause the video, and I'm going to put the answers on the board now. Okay, so if dy by dx is equal to 8x to the power of 8, y is going to be equal to x to the power of 9 divided by 9 plus c. Second one, dy by dx is equal to 2x to the power of 5, y is equal to 2x to the power of 6 divided by 6 at the constant, and we can reduce this. So 2 goes into both of those, and we get x to the power of 6 divided by 3 at the constant. For the next one, 4x squared, add 1 to the power, divide by the new power at the constant. Now this last one, we'll do it in 2 stages. First of all, take the first term, 3x to the power of 5, that will become 3x to the power of 6 divided by 6. And then the second term, 6x to the power of 3 at the constant. And of course we can simplify these, so we're going to have x to the power of 6 over 2 plus 3x to the power of 4 over 2 plus the constant. Okay, I think that is the end of the first lesson.